Hi, everyone. Welcome to our LinkedIn Live series, part 2. This is entitled Under the Hot Rod Hood, the Data Science of AI, affectionately named that way from my love of cars. But we're going to focus on really diving a little bit deeper in our discussions in this series around some of the nitty-gritty of how we as practitioners work with AI and provide responsible, ethical, and safe decisions for our customers. The first part of this is breaking down the black box of AI with interpretable models. And I'm really super pleased to have one of my favorite collaborators and colleagues, Agus with me from Wells Fargo. He is the EVP and head of corporate model risk at Wells Fargo. And I couldn't think of anyone better to join me in this discussion around the importance of interpretability, breaking down black boxes of machine learning, and really talking about what the future of regulated and non-regulated environments could look like and maybe should look like in the guise of the upswell of interest in interpretable models. So, Agus, welcome to this LinkedIn Live series.
Thank you, Scott. Thank you for the opportunity. This is always a pleasure having a chance to talk to you.
Thank you. So one of the things that I think that I monitor this. I'm very passionate about responsible AI and interpretable models myself, and I'm kind of feeling pretty encouraged, right? I'm encouraged to see that more and more people are making decisions about the algorithms they use to run their businesses. They're becoming more and more educated, partly because we have more regulation out there and guidance, whether it be the GDPR or IEEE 7000, or just really strong governance processes that will, that enforce and educate people around the use of machine learning in responsible ways. And I think, in my view, Agus, it would be great in that guise to tell us a little bit about your role at Wells Fargo.
Yeah. My role as head of model risk for Wells Fargo, basically the buck stop at me, right? For any model that will be deployed in live production. So at the end of the day, I am responsible for that. Anything that's trouble that created by model will be my responsibility. And I report to the chief risk officer, who report to the board risk committee, basically. So we are a very independent function, independent groups that to make sure that we deploy any model responsibly. We set standard and we say what can and cannot do for people to when apply model.
Perfect. It's a super important role, right? One of the things that as I started to think about model governance and responsible AI, I would talk to customers, and many of them at the CRO level would say, 90 to 95% of the models we build, we never put in production. Right? And because of the need for very, very strong model governance and standards. And some people will look at that and say, well, that's really poor, right? Because there's a lot of wasted effort. But I always thought, well, that is it's evidence of an organization that is really serious about not impacting people's in negative ways, because there's not this level of satisfaction around how the model was developed and governed. What's your thought about that? I mean, I'm sure those things are better these days with more process, but
right. I think it's really depend on the maturity of the organization. I would say, Scott, we've been, I think, particularly large bank has been in this journey for more than 10 years. So at the level of some organization very mature, some organization probably less mature, particularly probably smaller institution. So in our case, we have very, very mature process. So we have in Wells Fargo, we have 8 model development team across company. So we are very somewhat centralized, decentralized, because we have 8 teams supporting different line of business. And when we talk about model risk management, about developing and using and deploying model responsibly, our model developer really is in their DNA now. So the role of model risk management and the role of model validation becoming like parents, you make sure that the kids are really safe. If you have teenager, they will be in safe behavior all the time. So I think it's like that. So it's really, we have very, very mature practice, mature organization. So we don't have something that if you talk about 90% model not going to production, probably true in the exploration, because people do a lot of exploration, and they should do it because they try to find a lot of different things. But as we decide, okay, this is what we're going to do, this is direction to do, I think we have very, very, very high success rate today in close to 100% today in terms of success rate. So I think it's really maturity of organization, how they know how to manage model risk, because we know our model will be wrong at some point in time. And this is also true in the machine learning and AI, more complicated model. A very, very well trained organization, I would say, like you're going to drive you're a car guy, you want to drive a fast car, you need to have an expert driver, well trained driver. So our model development team, the COE, is in that stage. We know if they develop it, they are expert driver, they know how to drive fast and safely.
That's great, and I think it's I love the feedback around a 10-year journey and really getting to that level of maturity. The other thing that I really that I really like to hear, and it's something that I think that's super important, is when I talk about responsible AI and model model development, I talk about model development governance, and I think you're absolutely correct, right? Those that are developing the models need to understand and anticipate and really reflect upon how the models are governed and what that standard looks like. And when that occurs, right, things, you don't have that car crash, right, where it's a beautiful model, but the governance team says no because of XYZ. They know exactly what the rules of the road are. And they also, great companies that have this done very well, have, published model development governance documents across the board, right? So there's not a different standard for Scott than for Sally or someone else. It's just simply a standard, and that becomes part of the DNA, as you say. So I think that really reflects and probably defines really mature companies that are doing this well, because then you can focus on the standard, right, and improve the standard over time, right? And incrementally get better versus having to put out fires or have these sort of high reject rates on models. So one of the key things that I think is really important from a model governance perspective is around interpretability, right? And the work that I do at FICO, we focus on a class of models and special algorithms that I focus on, which are interpretable neural network models. And I know interpretable models are tremendously important to you and to your business. So can you just kind of expand on why is that so important to you, and maybe also share with everyone some of the work that you've done with some of the RayLu sort of models and why you use that. I think it'd be really helpful for everyone to understand, because I think many that are listening in, may not know that it is possible to not choose the black box, right? It isn't black. So can you give some feedback and some insight there from your perspective, Agus?
Very, very good. Thank you. And this is very, very question that really near and dear my heart, and we practice it every day here. I think what I would like to start is the misconception in terms of interpretable model first, and then also the some kind of terminology that is already out there that I think somewhat misnomer in our view. People talk about explainable AI and all those things. So I think we have to be very, very mindful about that. So first, start in terms of the misconception of interpretable model first. When people think about interpretable model, a lot of people think about this is the old-fashioned statistical model, linear model, or some sort of that variation of that, but the traditional statistical model. But when we talk about interpretable model, interpretable machine learning, it's way beyond that. You have developed this for a while on the how to make neural networks interpretable by controlling the architecture. We work a lot on this subject as well. So we're thinking about, okay, if you want to do gradient boosting machine, if you want to do deep learning, how to make this one, how to design it to be inherently interpretable from the ground up. We control the architecture of the model. We control how we build the model and control the architecture so that the model inherently interpretable. When I say model inherently interpretable, is you don't need auxiliary tools to understand what the model is and what the model does. And any interpretation of that will be exact. So I'm taking the parallel of linear regression, the simplest thing, right? Is I have the coefficient. I understand the coefficient, and that's I can interpret it basically. So of course, if you have regression with high order interaction, that may not be interpretable too. So how to you still have to even simple regression model, you have to constrain it to make it interpretable. So when we talk about this, and I want to bring it here, your point as well. People tend to jump to a black box model. I'm going to apply gradient boosting machine. I'm going to apply a neural network, deep learning to build model, and probably typical things that people do, and a lot of activity doing this. They run auto ML, right? They run all hyperparameter tuning, all kind of different model, and pick the best. And that's the best is the model that is the winner in the leaderboard, the ones that I pick. Well, that it can be very, very dangerous thing in the machine learning and complex model. First is model that perform the best may be model that doesn't make sense. So you can have, especially in the world of machine learning, you can have all kind of hyperparameter tuning, and all kind of different model will have very, very similar performance or the same performance. Yet they are totally different model as you look at under the hood. You look at the what is the effect of variable. For example, if you look at the effect of payment status, the longer people delinquent, it should be the higher probability of default, right? So you look at from 1 month ago, 2 months ago, 3 months ago, but if you just throw in machine learning, you can get very, very nonsensical stuff. Your model still perform very well with the testing data that you have. But the world changed. So when the world changed, model that nonsensical, it's going to crumble. So what do machine learning do? They retrain it. When they retrain it, basically is refitting noise, right? You do overfitting noise, you just keep refitting your noise. So you have model that's gonna crumble like that. You and I live in the world on the credit decisioning, for example. When we make decision on credit decision, we originate customer. These customers stay with us for a long time, in good time and in a bad time. Our decision that we make still have to be good, regardless of the time difference, and things changing. So that's, you cannot just chase the tail, take the leaderboard on AutoML and have nonsensical stuff. So this is where inherently interpretable model is very, very important. And now I said, well, it need to be inherently interpretable because we cannot just slap in additional tool to really understand this black box and give us sense of false security that I understand the model. No, you don't. So that's the thing. When people applying some of the post hoc explainability tool, they think they understand the model. Reality is you don't. So it's still a black box. Your model is black box. You apply that, it doesn't make your model explainable. It's not. You just try to explain the model. And by the way, that explanation can be very wrong very easily. In particular, for machine learning, when we're dealing with highly nonlinear or potentially overfitting. So that's the type of thing. Now, when we apply model for critical area, deciding the livelihood of people, the future economics of the people, the future wealth of the people, their ability to access financial resource, then this model have very critical impact to people livelihood. So
Indeed.
in that situation, you really need to make sure that you understand the model and your model make the right decision and sensical. And that's what I'm against deploying any black box model with, even if you apply explainability for something like credit decisioning, for credit approval. So I'm really against that because we have a lot of tools available to build inherently interpretable model.
Right.
You have this, right, Scott? You have your techniques using neural network, control it. We do have it. We use neural network as well. Let's say I can use ReLU, for example, using ReLU activation function, because ReLU activation function is very simple. It will be linear. If that node is on, it will be linear equation, get linear, get propagated. If it's the nonlinearity coming, if it's not, if it's below certain threshold, will be zero. So you have a RAM activation function to create nonlinearity. But when when the node is on, it will be linear, and linear propagated still linear. So every point degenerate into linear equation in neural network using ReLU activation function. It can be so many of them depending on the size of the network. And we need to control this piece because this can do anything. It's just like piecewise linear spline. This just no more than that. It's just multivariate piecewise linear spline. It can do a lot of things. So then we have to, okay, now we know it's locally will be linear, every point associated to linear model. Nothing more interpretable than linear model. So it's very simple, right? Because linear you get interpreted, but we are dealing with too many of them. So what do we do when we deal too many of them? So we have two choices. One is, let's reduce it, the number of linear equation. Let's reduce it. If you do thinking about segmented regression, instead of 1,000 or 100,000 segment, reduce it to make it more digestible to people. That's for one. Two is more controllable because we're dealing with finite set that we can control very, very well. So how to do that? Well, you can regularize it. You can apply L1 penalty. You can apply L0 or thresholding to reduce the number of local linear model. If you reduce it so much, it will end up with single equation boiled down into logistic regression, right? So this one is, okay, if it's two, I have two logistic regression segmented. If it's three logistic regression. So it depends, you can control it. So that's one. If you want to use fully connected ReLU network, you can control it like that. The second approach is, let me control the architecture. I don't want to just fully connect it. Let me control it. I can control it, neural network, to implement generalized additive model, GAM, right? GAM with piecewise linear spline. You can do it. GAM is very, very interpretable because you can see every fragment, say, oh, GAM is not enough. I want to improve it. Put second order interaction. Then I have GAM with interaction to whatever interaction level that you can do. And you can deploy that as a neural networks. So that is very controlled, very well behaved, and we know it. Similar thing, if people like to do a gradient boosting machine, they can do it too, doing like that. Okay, I'm going to implement a GAM using gradient boosting machine, which is, if it's, or I can control the depth of the tree into single just tree stump, one depth. That will boil down becoming into GAM, just like the traditional logistic regression model that we do with sophisticated binning, because you bin it differently. So people can control it. Rich Caruana from Microsoft control it by putting GAM with interaction as well. So that can be applied, and high performance as well. And then other approach, there are many other approaches too, like Cynthia Rudin using mostly a rule-based system. So that can be done as well. So there are a lot of variety, sophisticated machine learning model that people can apply. We just need to educate ourselves and understand how to build this properly.
Yeah, no, I mean, there's so many great things that you packed into that, right? I mean, I think, just to call out a few, and I agree with everything you said, right? Number one, right? We don't, this is not a Kaggle competition, right? These are people's lives, right? And understanding these models and how they behave, particularly out of time, right? Out of sample is super important, right? So, people don't really reflect on that, right? The fact that a model that's interpretable, a model that's a little simpler, right, and less complex is inherently more understandable, and we have more faith in as we work with this, in production, right?
Right.
I also am a firm believer that applying tools that you barely understand, let's say explainable AI methods, on top of a model that you barely understand or don't understand, right? Two wrongs don't make a right, and
Okay.
so what I really like about this conversation, and what I really like about your approach is just this. And I think if we leave people with this sort of notion that it is our decision around, what are the business requirements? What are the responsible AI sort of tenets that we're going to implement from a technology perspective, not from a good intentions perspective, but from a technology perspective around, the transparency, around the coverage, around the fact that, we need to monitor and understand how this works out of time, I think is critically important. And methods, right?
I think that's very, very important things, Scott. That very key point that you talk about. Model that will work out of time, right? The things that change, and this is something that I think a lot of things that get neglected by people that using machine learning. And I want to say this because this is very critical. When people build machine learning, typically I split the data, training and testing. Then you do hyperparameter tuning. You look at the testing data. Based on testing data, this is best. We're going to pick that. Well, that's under very, very strong assumption that world doesn't change. That your testing data, right? It's just like that. When you split data, randomly split data, your testing is still coming from the same distribution of your training. So with that, more complex model, get good performance, give you over optimism that the model will work well. In reality, it won't. So how you test model that will be robust under distribution shift? You and I know in the practice, we do monitor data drift all the time using PSI or KS statistics and all of those things to look at how the data drift. So model that's more complex, black box, they can get good performance, but have you tested under distribution drift and see if that model performance will stand? In our experience, model that is very well regularized, very controlled, those inherently interpretable, if you test it in terms of robustness and resiliency without of distribution, it will perform better. Very likely it will perform better. So when we build model, we only think about model stability, model robustness, model resiliency, not only, based on the testing data that I have, it perform best. So I think the community need to move away from that mindset, from the simplistic mindset of I just do based on testing data and I pick a model. Unfortunately, all the tool is like that today.
Absolutely, right. I mean, I think, what we see routinely is, these more complex models degrade almost instantly, right? And all that work that's been done is somewhat invalidated because it's probably learned nuances of that, in time sort of sample. And I think, models are only good when they're used, right? And the time, right? And so, this is not an academic exercise, right? It's not to show that you can build a better model than mine. Right. It is essentially when we impact people's lives and we use it in production, we need to have confidence in it. And, beyond that, right, like in some of the work that we do on my side, right, I want to isolate every latent feature and I want to understand, I want to monitor those latent features, right? And when things shift in the world, and they do, and they're shifting right now, and they will continue to shift for the rest of our lives, right? I'll understand how some of these latent features are moving and changing. And the other big thing, Agus, that is really important here, I think, is that sometimes people lose track of, and it's something I'm spending a lot of time on, is it's not, the model's super important, but then we have this whole sort of, decisioning, intelligent decisioning that comes after it. It's predicated on the behavior of the model. So if that behavior changes out of time in a more dramatic way for a really complex model, now all your decisioning is off, right? So
Correct,
you're
correct.
not you may not have a responsible model, you don't have a responsible decisioning.
Correct. And that's very important, Scott, because we talk a lot about human in the loop. Now, if you want to put human in the loop, the human that need in the loop need to have a gist in terms of what is the outcome decision of this. An interpretable model facilitate that. The human understand it. If it's wrong, they know what to do.
Yes.
If they, I think it's so critically important to have model that interpretable, that the human that in the loop, the decision maker, if they need to override the model, really understand how to do it. So I think that's
absolutely no. It's critical, Agus. I mean, we can't separate the model from the decision, and the decision from the human. And I think we need to see this full picture. And we're coming to the end of our talk, and you and I think we could talk for a long time around these topics. But I guess maybe just to wrap us up, I mean, what's your thought about where the industry is going, right? I mean, I think there are leaders like yourself and I, Cynthia, others that really focused on this as important. We're trying to educate our peers and be best examples of this, and I think we'll get there. But what's your view, right? I mean, in terms of will we get there, and at what pace will we get there in terms of interpretable models being a standard that maybe financial services will adopt because it's so important?
Yes. I think it's you and I is kind of tirelessly evangelize this, right? But I think is with the lot more attention, sensitivity of people toward algorithmic decision making, the public opinion and the sensitivity, because now algorithmic decision, and of course with the regulator as well on this. I think this is the time that we need to really seriously looking into this, not just let's on new things, technologies. Since it's something that I'm worried about, if somebody publish it and then or put it, then people believe it's true, and that's something that we have to be careful about. In particular, the expert know about what's the danger of some of the things, but the most user don't. And I think this is the direction that we need to go if we want to be successful on this, not having a backlash. Okay. I think we need to really use model responsibly, and big part of that is using interpretable model.
Agreed. Well, I appreciate you fighting the good fight here, Agus, and I'll continue on my side. And I think it is an education. It's going up against, some of the sort of, the Kaggle sort of contest sort of mentality out there. And, no one better than, leaders in model governance and best practices here to ground us to what reality is, which is these models make really impactful decisions for our customers, and ones that we all, as analytic leaders, need to be very concerned about and hold with a huge amount of responsibility. So I thank you for your thought leadership there. I also want to thank everyone that has joined us today. I'm really pleased to have this second series of LinkedIn Live. Keep an eye out for the next one. We have a number of interesting topics here, but this has been really fascinating, Agus, and thank you for sharing your expertise with the audience here. I appreciate that.
Thanks a lot, Scott.
All right. Thank you, everyone. Bye-bye.
Bye.